Singapore is at the forefront of a green maritime revolution. As part of our ambitious 2050 net zero goal, the Maritime and Port Authority of Singapore is leading the charge to electrify our harbour craft fleet. By 2030, all new harbour craft operating in Singapore waters must either be electric, capable of running on B100 biofuel, or compatible with net zero fuels like hydrogen. This is a significant step towards decarbonising our maritime sector and reducing our environmental impact. The Singapore Maritime Institute, SMI, is collaborating with MPA to support research that will pave the way for a more sustainable net zero future. Other than electrification, we are also exploring other promising alternative fuels, including methanol and ammonia. In this research spotlight, we are excited to showcase innovative research projects that are pushing the boundaries of maritime technology. These projects are at the heart of our mission to create a cleaner, greener, and more sustainable maritime industry.
Shipping plays a crucial role in international trade, but also has a significant carbon footprint. At MESD, our research on biofuels supports Singapore's maritime decarbonisation efforts, contributing to a more sustainable environment as we align with global sustainability goals.
There are many variations of biofuels available in the market. Biodiesel is a completely renewable and biodegradable fuel source, and B100 is a 100% biodiesel blend. The ingredients and means of producing B100 are accessible in our region, making B100 a prime candidate for our study.
We have identified some gaps in biofuel implementation, and the focus of our study is to address them through extensive tests and trials with the support from our industry partners.
Building from prior studies, we have converted the specifications of our test bed into a digital model to run CFD simulations that give us a cost-effective benchmark for performance. CFD is utilized to assess engine performance when using aged biofuels.
We are currently testing the storage potential and fuel quality with additives across 4 different blends of B100. Each blend is stored for 1.5 months in a sheltered outdoor environment between each test to track key parameters, and we repeat it 3 times across 4.5 months. With our final results, we can compare the performance of different additives and their effect on biodiesel quality through blending the different batches.
With data from our fuel blend tests and CFD simulations, we are moving on to the next phase of trial B100 on 2 larger harbour crafts. We are working closely with vessel owners, outfitting their ships with different sensors to measure the performance and give insights into the operational challenges we need to be aware of.
We are now past the midway point of our studies. With trials commencing, we are excited by the potential of B100 biofuels as a sustainable alternative for harbourcraft operations in Singapore waters.
As a national R&D center dedicated to the maritime and offshore sectors, our expertise lies in digital twinning of harbourcraft behavior and response. The Hydromover is Singapore's first fully electric cargo vessel. This project, in collaboration with CTech Solutions and Insun Green Tech, allows us to contribute to harbourcraft electrification and decarbonisation of the maritime industry. Through our studies, we uncovered the challenges, limitations, and possibilities that harbourcraft electrification presents to us.
We started by collecting the operational, technical, and third-party data surrounding the Hydromover to get its operational profile. This gave us the baseline data for the ship performance and energy usage. This data can be used by the ship designers in sizing the battery for the electric vessels. We dive deeper into our research by creating an integrated model to understand each of the ship's component systems, how they function alone, and how each system led to and affected the next. The integrated model can be used as a digital twin for the Hydromover in the management of range anxiety with more accurate and reliable information about the remaining battery range.
With the operational profile and integrated model in hand, we moved to the next phase, running the digital twin in different weather conditions.
Operational simulations enable us to safely stress test the limits of the vessel from calm to challenging weather conditions, giving us actionable data for operational planning. The hydrodynamic digital twin, with access to real-time weather forecasts, provide actionable insights for vessel operators to know their energy requirements across the board, to plan for optimal journeys and to be prepared for challenging ones based on weather and tidal conditions. Maneuvering digital twin using real-time weather data, where we map vessel movement and performance in Singapore's busy waters, can serve as a guideline for safer piloting of electrified hovercraft in the future.
We have gained valuable data on how the hydromover operates in our waters. Through this study, along with our partners, we created a comprehensive framework that can be applied to other electric vessels and help improve the development of future electric hovercraft.